All right, for the section 6 notes, what we are talking about are we're graphing inequalities. So not graphing them on a number line like we've done in the past. Now we are graphing them on a graph with two variables. So we're going to have an x and a y in our inequality, okay? But we're going to solve it not any more challenging than what we've solved in the past, all right? So the biggest thing we're going to need to reflect back on is you guys are going to need to remember this. Darn it, I can't get my pen pulled up. Y equals mx plus b. So that y-intercept form that we talked about back in chapter 4. All right. So with this, remember the m stands for our slope, which is our rise over our run. And b is our y-intercept, or where we cross the y-axis. All right. So when we go to do these problems, you're going to need a slope, you're going to need a y-intercept, and then from there, the part that is different is not hard at all. What you need to know is if you're graphing a greater than or equal to sign, you're going to use a solid line. If you're graphing just a less than or just a greater than sign, we use a dotted line. And that's pretty much the main difference. And we're going to have to shade like they showed up here. We're going to have to shade on one half or the other for the graph, but I'll show you how we figure out which half to shade on, and it's not hard. Okay? So if we look here at example 1, it wants us to graph. Before we can graph, we need to make sure we have everything written in this y equals mx plus b. No, we're not going to have an equal sign. We're going to have an inequality sign, but they act the same in terms of solving this, okay? So we have right now 3x minus y is less than 2. I want to get y alone, right? I want to get y over here. See, y is by itself, so we're going to get y alone. Right now I have a positive 3x. So I'm going to subtract 3x from both sides to get it to go away and get just a negative y over here. I want the x in front, so I'm just going to write it in front. It's going to be negative 3x. That's a positive 2, so it becomes plus 2. From there, okay, From there, you just need to get rid of this negative sign that's with my y. So I have negative y, which means I actually have negative 1y. If I want to get rid of that, I'm going to divide both sides by negative 1. This becomes y. If I divide it by this negative 1, we still have to flip that sign. That rule is not going away. You divide it by a negative, you flip the sign. So now y is greater than negative 3 divided by negative 1 would become a positive 3x, and then plus 2 would become minus 2. Okay, so you're just changing the sign of everything in there, basically. So then you would go graph this. Your m is 3, which we always want this to be a fraction. So we have 3 over 1 because we want a rise over a run. Our b value is minus 2. The original form is plus 2, so since it's minus 2, it means it's negative 2. All right, so what you do to graph, you go and you put your first point, then they already did it here for you, but I'm going to go over it just in case. You put your b value down first, which is at negative 2. It's where I cross the y-axis, so I come down on my y-axis and put a point at negative 2. Then my slope is rise 3, run 1. So that means I'm going to rise 1, 2, 3, and run to the right 1. So there's your other point, and you just repeat. Okay, you can also do it backwards because lines go on in both directions. All right, and then you just, because it has a no equal sign, we're using a dotted line to draw our line. All right, and then, okay, now our line is graphed. So we just need to figure out which side are we going to shade on. So that's part 2. How do you figure out where to shade? You select the origin, the point 0, 0. You always want to select this point because it makes things easier. Are there going to be occasions you can't use that point? Yes. If your line is going through the origin, then you can't use the origin. But in this case, we're not, and in most cases, you won't. So you can use the origin. So you're going to take that and you're going to plug it in. Okay, so your inequality is y is greater than 3x minus 2. Plug in the origin, which is 0 for y, 3 times 0 for x minus 2. That becomes 0 is greater than 3 times 0 is just 0, so it disappears. And you're left with just negative 2. Is 0 greater than negative 2? Yes, this is a true statement. So that means go find the origin on your graph. All right? Since it's a true statement, that means the origin is on the shaded side of the graph. So you would shade that side. All right? And that's it. That's how those work, okay? So I want you guys to try these 2 guided practices and then check in and see if you got them correct. All right, so on 1A, what you do is you pull out your M. Your M was 1/2, your B was 3. So I started by graphing. I went up and graphed my y-intercept at B. And then I applied my slope, which was rise 1, run 2. So I went up 1, right 2, up 1, right 2, and so on and so forth. Then I came and did the second half of the graph, and I went down 1 left, down 1 left, down 1 left 2, down 1 left 2, all the way until I reached the end of the graph. All right, we do not have an or = 2 sign, so we used a dotted line on our graph, and you connected. All right. To figure out my origin, I plugged in 0. I plugged in my origin point right here. And I got 0 is greater than 1/2 0 plus 3. And that left me with 0 is greater than 3. That's a false statement. 0 is not larger than 3. So that means I put an X through my origin and I shaded the other side of the graph. All right. Same thing over here. I wrote it the other direction just because this is the way I'm used to seeing it, but it was already in slope-intercept form. They just put the y on the other side, which we just don't like it over there. So I rewrote it. That left me with no number in front of my x. That means it's actually just a 1 hidden there, so it becomes my slope of 1, or 1/1, because we want it to be a fraction, and a y-intercept of -1. So I graphed my y-intercept at -1, and I went up 1 and over 1 every single time and connected it all with a dotted line. Okay? It's dotted because we don't have the or equal to. Remember that part. Then I plugged in my origin. 0 for y is less than 0 for x minus 1. 0 is less than -1. 0 is not less than -1. That was a false statement. So again, I put an X through my origin and I shaded the other side of the graph. Okay? If you look at example 2, we have x plus 5y is less than or equal to 10. Again, the first step we need to do is to get this in form y equals mx plus b. We want to make it look like this. All right? So I'm going to solve for y. So I'm going to subtract x as my first step to get rid of that. So that'll leave me with 5y, because those are gone, is less than or equal to, I want the x in front, so negative x, and then it's a positive 10, so plus 10. Now I have 5 times y. I want to get rid of the 5, so I'm going to divide both sides by 5. Those leave. Y, I didn't multiply or divide by a negative, so I leave the sign alone. Negative x over 5. So you're going to do this. This would become negative 1/5 x, and then you take 10 divided by 5, and you'll get 2. All right. So my m is negative 1/5. My b is positive 2. So I'm going to come over here and I'm going to graph up 2 and put my y-intercept down. And then I have a slope of negative 1 over 2. That means I rise negative 1, which means fall 1, and then run 5. 1, 2, 3, 4, 5. Or you could rise 1 and go to the left. 5. We have the or equal to sign. So these are going to get connected with a solid line, not a dotted. Okay, we only use the dotted line when you don't have the or equal to. But to figure out which side to shade on, you still do the same thing. You take the origin at 0, 0, and you plug it in. Okay, so 0 is less than or equal to negative 1/5, 0 plus 2. 0 is less than or equal to 2. That is a true statement. So I'm going to shade the side the origin is on. Again, pause, try 2A and 2B. Okay, so on examples 2A and 2B practice, I only gave you one graph, so you guys might have only done one, and that is fine. But I did them both for you, so because I have multicolored pens and I can do 2 graphs on one coordinate plane. You should not. So for the first one, I solved x, I moved x over, so it left me with y is greater than or equal to x minus 3. Once you divided out the negative, that gets left with the y. You'll get a slope of 1 over 1 and a y-intercept of negative 3. So I came down, graphed my y-intercept at negative 3, and went up 1 over 1 every time. I had an or equal to sign, so it was a solid line. And then over here you can see where I plugged in my origin. 0 for y is greater than or equal to 0 minus 3, so is 0 greater than or equal to negative 3? That was a true statement, so I shaded the side that the origin was on. Over here from my red graph. Okay, I did the same thing. I started solving for y, subtracted over 2x, then I divided both sides by 3 to get y is greater than or equal to negative 2/3 x plus 6. Plug in your 0, so I went and graphed it. Sorry, I didn't write out my m and my b on this one. My m is negative 2/3 and my b is 6. So I went up to my b, and I went up 6 and put my point, and then I went down 2, right 3. Down 2, right 3, down 2, right 3, and then I went up 2, left 3, up 2, left 3 to get the negative 2/3 slope, right? When I went to plug in my origin, I got 0 is greater than or equal to 6, and again, that's false. 0 is not bigger than 6. The origin was below the line, which means I wanted to shade above that line. All right? Okay. If you look at example 3, okay, they've given you the graph, you got to write the inequality. All right, so basically what you need to do is fill in my blanks. Here's my y, here's my x, and I need to fill in b, m, and the inequality symbol. So I have a circle here, I have an m, and I have a b. All right. So if I'm going to start by finding m and b. B is what we graph first. It's also the easiest thing to go find first. So go figure out for B where you cross your y-axis. I cross my y-axis at negative 3, so my B value is negative 3. To figure out your slope, go find the next point that crosses right at 2 numbers. So right here, I'm right where the 4 blocks meet. I'm right at the 4-corner meeting point. So I'm going to go up 1, 2, and I rise 2, and I ran 1, which is just equal to 2. All right, so we're kind of like working backwards. So I'm going to fill those in. I have a 2, and I have a negative 3. Now I need to figure out what type of inequality symbol am I using. Well, I have a solid line, so that tells me I'm definitely going to have an or equal to in it. And then I just need to figure out what happens when I plug in the origin. When I plugged in the origin this time, I shaded on that side, which means when I plugged in the origin, I got a true statement. So you want to know when you plug in 0 for 2 times 0. So when you plug in your origin, what do you get? Because you got a true statement, so you're just going to make it true. 0, 2 times 0 is 0, plus negative 3, so it's just negative 3. 0 is larger than or equal to -3. All right, this is true. That matches with shading the side the origin was on. So the symbol we have is a greater than or equal to sign. So your final answer would be y is greater than or equal to 2x. You don't have to write the plus negative, just minus 3. All right. Okay, take a second and try guided practice 3. Okay, so when I went to do this, I found my b first. My b crossed at 1. So I put 1. My slope, I counted what I needed to do to get to the next point where it crossed. So I went down 1, 2, 3, 4. So I got a -4, and I ran 1. So it was -4 over 1. I went to the right one, so it was a positive 1 on the bottom. Okay. From there, I plugged all that information in. I plugged in my m, and I plugged in my b. I just needed to figure out what is my symbol going to be. I knew I wasn't going to have an or equal to sign because I have a dotted line. So I was just looking for greater than or equal to. I knew it had to be true because I shaded the sign that the origin was on. So when I plugged in the origin, I end up with a 0 and a 1 on either side. And for that to be true, 0 is less than 1. So it was a less than sign that went there. All right. Here's the homework assignment. Okay, so you got to complete that and turn it in.